Quadratic equations, the equation of variables of second order.
Quadratic equations. In algebra, a quadratic equation, in the variable let's say x, takes the form a times x squared plus b times x plus c equals 0, where a, b and c are real constant. The equation is a quadratic because in one of the term, a times x squared, the variable x is raised to the power of 2. To solve such quadratic equations, two methods are generally used. Method 1. Factorization and null factor law. Method 2. Use of general quadratic formula. Method 1. Factorization and null factor law. To solve, bring all the terms to the left-hand side and make right-hand side equals 0. Then apply null factor law. Remember the null factor law, which states that if the product of two variables is 0, then either the variables is 0 or both the variables are 0. If x times y equals 0, then either x equals 0 or y equals 0, or both x equals 0 and y equals 0. If x plus 2 multiplied by y minus 3 equals 0, then either x plus 2 equals 0, or y minus 3 equals 0, or both x plus 2 equals 0 and y minus 3 equals 0. Factorization by number 1. Trial and error. X plus alpha times x plus beta equals 0. Number 2. Perfect square. X plus alpha whole squared or x minus alpha whole squared. Number 3. Difference of two squares. X squared minus alpha squared equals x plus alpha x minus alpha. Method 1. Factorization and null factor law. Case 1. When a equals 0, or x squared plus bx plus c equals 0, there are three ways to solve the equations. Number 1. Factorization by trial and error. Rewriting the given quadratic equation in the form like x squared plus alpha x plus beta x plus alpha times beta equals 0, which can be factorized as x plus alpha times x plus beta equals 0. So the solution could be either x plus alpha equals 0, therefore x equals minus alpha, or ex plus beta equals 0, therefore x equals minus beta. Number 1. Factorization by trial and error. Example 15. Find the solution for x squared plus 12x plus 32 is equal to 0. In this method, the solution depends if we find the factors of number constant such that the factors add up to the coefficient of x. Here factors of 32 is equal to 8 times 4 and 8 plus 4 is equal to 12, which is the same as the coefficient of x. In the equation, x squared plus 12x plus 32 is equal to 0. The constant 32 has factors 8 and 4, which adds up to 8 plus 4 is equal to 12, which is the coefficient of x. Break 12 into 8 and 4. Or x squared plus 8x plus 4x plus 32 is equal to 0. Take the common factors out and form the bracket. Or x times x plus 8 plus 4 times x plus 8 equals 0. Or ex plus 8 times x plus 4 equals 0. Either x plus 8 equals 0, therefore x equals minus 8 is the solution number 1. Or ex plus 4 equals 0, therefore x equals minus 4 is the solution number 2. Take another example. Solve. The equation x squared plus 12x minus 28 is equal to 0. Note the constant minus 28 has factors 14 and e minus 2, which adds up to 12. Or rewriting, x squared plus 14x minus 2x minus 28 is equal to 0. Take the common factors out and form the brackets. X times x plus 14 minus 2 times x plus 14 equals 0. Or ex plus 14 times x minus 2 equals 0. Apply null factor law. Either x plus 14 equals 0, therefore x equals minus 14 is the solution number 1. Or ex minus 2 equals 0, therefore x equals 2 is the solution number 2. Number 2. Factorization by making it a perfect square. Either x squared plus 2 alpha x plus alpha squared equals x plus alpha whole squared. Or x squared minus 2 alpha x plus alpha squared equals x minus alpha whole squared. Example 17. Solve x squared plus 12x plus 36 is equal to 0. Before you try this method, first check is constant in equation is positive and a square of an integers is coefficient of x is double of that integer. In this example, the integer is 6. So x squared plus 2 by 6x plus 6 times 6 is equal to x plus 6 squared. Or ex plus 6 equals 0, therefore x equals minus 6 is the solution. Example 18. Solve the equation x squared minus 8 times plus 16 is equal to 0. Before you try this method, first check. Number 1. Is constant in equation is positive and a square of an integers. Number 2. Is coefficient of x is double of that integer. In this example, the square root of 16 is an integer 4. X squared minus 2 times for x plus 4 by 4 equals x minus 4 whole squared. Or ex minus 4 equals 0, therefore x equals 4 is the solution. number 3 make it a difference of 2 squares. X squared minus alpha squared equals x plus alpha times x minus alpha. Example 19, find the solution for x squared minus 16 is equal to 0. Equals x plus 4, x minus 4 equals 0. As per null factor law, solution is either x plus 4 equals 0, therefore x equals minus 4. Or x minus 4 equals 0, therefore x equals 4. Example 20. Find the solution for x squared minus 5 equals 0. Since 5 equals square of square root 5 equals x plus square root 5 times x minus square root 5 equals 0. Solution is either x plus square root 5 equals 0, therefore x equals minus square root 5, or x minus square root 5 equals 0, therefore x equals square root 5. Case 2. When a not equals to 0. In trial and error method, the solution depends. If we find the factors of the product of coefficient of x squared and number constant such that factors add up to the coefficient of x. For example, find the solution for 2x squared plus 3x plus 1 is equal to 0. In this case, the factors of the product of the coefficient of x squared and the number constant is 2 times 1 is equal to 2. Such that factors 2 and 1 add up to 3. The coefficient of x, 2x squared plus 2x plus x plus 1 is equal to 0. 2x, x plus 1, plus x plus 1 equals 0. 2x plus 1 times x plus 1 equals 0. Either 2x plus 1 equals 0, therefore x equals minus 1/2. Is the solution number 1. Or x plus 1 equals 0, therefore x equals minus 1. Is the solution number 2. Second case, when a is not equals 0. Number 2. Make it a perfect square. A squared x squared plus 2abx plus b squared equals x plus b whole squared, or a squared x squared minus 2abx plus b squared equals x minus b whole squared. Before you try this method, first check whether coefficient of x squared and constant in equation are positive and a square of an integers. Whether the coefficient of x is double the square root of product of coefficient of x squared and constant in equation. Example 22. Solve for x squared plus 12x plus 9 is equal to 0. Or 2x squared plus 2 times 3 times plus 3 times 3 is equal to 0. Or 2x plus 3 whole squared equals 0. Solution is 2x plus 3 equals 0, therefore x equals minus 3/2. Example 23. Solve 9x squared, 24x plus 16 is equal to 0. Or 3x squared, 2 times 4 times 3 times plus 4 times 4 is equal to 0. Or 3x minus 4 whole squared equals 0. Solution is 3x minus 4 equals 0. Therefore x equals 4 thirds. Number 3. Factorization by making it a difference of two squares. A squared x squared minus b squared equals x plus b x minus b. Example 24, solve 9x squared minus 16 is equal to 0. 3x squared minus 4 times 4 is equal to 0. Or 3x plus 4 or 3x minus 4 equals 0. Solution are either 3x plus 4 equals 0. Therefore x equals minus 4 thirds. And 3x minus 4 equals 0. Therefore x equals 4 thirds. Example 25, solve for x squared minus 7 is equal to 0. 2x plus square root 7 times 2x minus square root 7 equals 0. Solution is 2x plus square root 7 equals 0. Therefore x equals minus square root 7 divided by 2. Or 2x minus square root 7 equals 0, or x equals square root 7 divided by 2.
General formula for solution of quadratic equations.
Method 2. Use of general formula. A formula that allows us to solve any quadratic equation. Solution to the equation ax squared plus bx plus c equals 0 is x equals minus b plus minus square root of b squared minus 4 times r into c whole divided by 2 times a. We give you the proof of formula that allows us to solve any quadratic equation. Left-hand side, ax squared plus bx plus c equals. Take common factor out. Since are not equal to 0, therefore x squared plus b say x plus c equals 0. Look the expression x squared plus b divided by a dot x. We make it a perfect square by adding any term b squared divided by 4a squared. To make it like the identity, a plus b whole squared equals a squared plus 2ab plus b squared. Add and subtract term b squared divided by 4a squared in the expression. X squared plus b divided by ax plus b squared divided by 4a squared minus b squared divided by 4a squared plus c divided by a equals 0. Since x squared plus 2b divided by 2a.x plus b squared divided by 4a squared equals x plus b divided by 2a, a whole squared. Therefore, x plus b divided by 2a squared minus b squared divided by 4a squared plus c divided by a equals 0. Solving it further. Left-hand side equals x plus b divided by 2a whole squared minus b squared divided by 4a squared minus c divided by a. We make whole expression. As difference of two squares, a second term has only constants. Factorizing using the identity of difference of two squares. X squared minus y squared equals x plus y times x minus y. Note steps of solutions carefully. As per null factors law, solution is either x plus b plus square root of b squared minus 4 times a into c whole divided by 2 times a equals 0, or x plus b minus square root of b squared minus 4 times a into c whole divided by 2 times a equals 0. If the solution is x plus b plus square root of b squared minus 4 times a into c whole divided by 2 times a equals 0. Therefore x equals minus b plus square root of b squared minus 4 times a into c whole divided by 2 times a. Or if the solution is x plus b minus square root of b squared minus 4 times a into c whole divided by 2 times a equals 0. Therefore x equals minus b minus square root of b squared minus 4 times a into c whole divided by 2 times a. Combining the two, therefore x equals minus b plus minus square root of b squared minus 4 times a into c whole divided by 2 times a. The discriminant. In the formula, the expression b squared minus 4 times a into c is known as discriminant. If the discriminant b squared minus 4 times a into c is more than 0, the expression can be factorized with two real solutions. If the discriminant b squared minus 4 times a into c equals 0, the expression can be factorized with one real solutions. Real solution is x equals minus b divided by 2 times a. If the discriminant b squared minus 4 times a into c is less than 0, the expression cannot be factorized with no real solutions. Now we take some examples to understand the method of solving the quadratic equations. Solve the three terms quadratic equation. X squared plus 9x plus 20 equals 0. First check the discriminant b squared minus 4ac. It is b squared minus 4ac equals 81 minus 80 greater than 0. Can be factorized with two real solutions. We solve it by trial and error method and look for two numbers whose product is 20 and sum is 9. They are 4 and 5. The product is 4 times 5 is equal to 20. But the sum of 4 and 5 is 9, so we rewrite x squared plus 9x plus 20 equals 0. as x squared plus for x plus 5x plus 20 equals 0. X squared plus 9x plus 20 equals 0. Rewrite it as x squared plus 4 plus 5, x plus 4 times 5 equals 0. Or x squared plus for x plus 5x plus 4 times 5 is equal to 0. Take the common factors out. So it is x times x plus 4 plus 5 times x plus 4 equals 0. Out the bracket, x plus 4 times x plus 5 equals 0. Hence, x plus 4 times x plus 5 equals 0. Solution is either x plus 4 equals 0. Therefore x equals minus 4. Or x plus 5 equals 0. Therefore x equals minus 5. Example 27. Solve the three terms quadratic equation. X squared minus 2x minus 15 is equal to 0. We solve it by trial and error method and look for two numbers whose product is minus 15 and sum is minus 2. We find there are 3 minus 5. So x squared minus 2x minus 15 is equal to 0. Or rewrite it as x squared plus minus 5 plus 3, x minus 5 times 3 is equal to 0. Or x squared minus 5x plus 3x minus 5 times 3 is equal to 0. Common factor out x times x minus 5 plus 3 times x minus 5 equals 0. Or x plus 3 times x minus 5 equals 0. Solution is either x plus 3 equals 0, therefore x equals minus 3. Or x minus 5 equals 0, therefore x equals 5. Example 28. Solving same the three terms quadratic equation. X squared minus 2x minus 15 is equal to 0. Now here, we solve the same equation using perfect square method by adding and subtracting a term. X squared minus 2x minus 15 is equal to 0. Rewriting 15 as 16 minus 1. Or x squared minus 2x plus 1 minus 1 minus 15 is equal to 0. Or x squared minus 2x plus 1 minus 16 is equal to 0. Or x minus 1 squared minus 4 squared equals 0. Now use difference of square identity. A squared minus b squared equals a plus b times a minus b. Watch the steps carefully, and you will get the same result. Example 29, solving same the three terms quadratic equation. X squared minus 2x minus 15 is equal to 0. This time we will solve it using general quadratic formula. Here A equals 1, B equals minus 2 and C equals minus 15. Check first, B squared minus for AC, equals for minus for times, minus 15. Equals for plus 60 equals 64 is greater than 0. And can be factorized with two real solutions. The general quadratic formula is x equals minus b plus minus square root of b squared minus 4 times a into c whole divided by 2 times a. Follow the steps carefully. You get the solution by general formula as x equals 1 plus minus 4. Solution is either x equals 1 plus 4 equals 5. Therefore x equals 5. Or x equals 1 minus 4 equals minus 3. Therefore x equals minus 3. Please note, the result is same as before in example 28. And example 29. X equals minus 3. And x equals 5. Example 30. Solve the three terms quadratic equation. 6x squared plus 11x minus 10 is equal to 0. Please note a not equals to 0. To solve, first check discriminant. B squared minus for AC is more than 0. So in the 6x squared plus 11x minus 10 is equal to 0. B squared minus for AC equals 121 minus 4 times 6 times minus 10 is greater than 0. We solve this equation by trial and error. Note in this case A times C is minus 60 and B equals 11. Now look for two numbers which are factors of AC equals minus 60 and possible factors are minus 1 by 60, minus 2 by 30, minus 3 by 20, minus 4 by 15, minus 5 by 12, and minus 6 times 10. The right pair of factors is minus 4 by 15 whose product is minus 60. And the sum is 11. So 6x squared plus 11x minus 10 is equal to 0. Or 6x squared plus 15 minus 4x minus 10 is equal to 0. Since 11x add smiley 15 minus 4x. Or 6x squared plus 15x minus 4x minus 10 is equal to 0. Or 3x, 2x plus 5, minus 2, 2x minus 5, equals 0 taking common factors out. Hence, 2x plus 5, 3x minus 2, equals 0. Solution is either 2x plus 5 equals 0 or 2x equals minus 5, therefore x equals minus 5 halves. Or a 3x minus 2 equals 0 or 3x equals 2, therefore x equals 2 or 3. The expression 6x squared plus 11 times minus 10 is equal to 0 compared to x squared plus bx plus c equals 0. In trial and errors method, we check factors for a and c separately, and cross-multiply and see if the condition of the right pair of factors, whose product is AC, in this case it is minus 60, and sum is matching the coefficient of x. In this case it is 11. we try making a grid with factors of a and c as below, and try to get right combination. Cross-multiplying these, and add the two products. See which combination matches the coefficient of x, that is 11. Third arrangement satisfies this condition, and possible factors are 3x minus 2 and 2x plus 5.
More quadratic equations with solutions.
Example 31. Solve quadratic equation. X squared plus 10x plus 25 equals 0. Check and compare with identity. A plus b squared equals a squared plus 2 times ab plus b squared. So rewrite the equation as x squared plus 2 times 5x plus 5 squared equals 0. X plus 5 squared equals 0. Therefore, x plus 5 equals 0. Solution is x equals minus 5. Example 32. Solve quadratic equation. X squared minus 10x plus 24 equals 0. Using trial method, we find possible factors as 4 and 6. Rewriting the equation. X squared minus 6 plus 4x plus 6 by 4 equals 0. X squared minus 6x minus 4x plus 24 is equal to 0. X times x minus 6 minus 4 times x minus 6 equals 0. Or x minus 6 x minus 4 equals 0. As per null factor law, solution is either x minus 6 equals 0, therefore x equals 6, or x minus 4 equals 0, therefore x equals 4. Example 33. Solve quadratic equation. 3x squared plus 9x equals 0. Note here 3x is the common factor in the equation, so 3x times x plus 3 equals 0. Solution is as per null factor law. Either 3x equals 0, therefore x equals 0, or x plus 3 equals 0, therefore x equals minus 3. Example 34. Solve quadratic equation. X squared minus 4x plus 3 equals 0. Using trial method, we find possible factors 3 and 1. Rewriting the equation as x squared minus 3 plus 1, x plus 3 equals 0. x squared minus 3x minus x plus 3 is equal to 0. X times x minus 3 minus x minus 3 equals 0. X minus 3 into x minus 1 equals 0. Solution as per null factor law. Either x minus 3 equals 0, therefore x equals 3. Or x minus 1 equals 0, therefore x equals 1. Example 35. Solve quadratic equation. 3x squared minus 12x plus 12 equals 0. Take out the common factor 3. 3 times x squared minus 4x plus 4 equals 0. Since 3 not equal to 0, therefore x squared minus 4x plus 4 equals 0. X squared minus 4x plus 4 equals 0. It matches with identity a plus b squared equals a squared plus 2ab plus b squared. Therefore, x minus 2 squared equals 0. Or solution is x minus 2 equals 0, therefore x equals 2. Example 36. Solve quadratic equation. X plus 1 divided by x plus 2 equals 0. Multiply the equation by x. X squared plus 1 plus 2x equals 0. Rearrange the terms. X squared plus 2 times plus 1 is equal to 0. It matches with identity a plus b whole squared equals a squared plus 2ab plus b squared. Therefore x squared plus 2x plus 1 equals x plus 1 whole squared equals 0. Solution is x plus 1 equals 0. Therefore x equals minus 1. Example 37. Solve quadratic equation. 5x minus 13 is equal to 6 divided by x. Multiply the equation by x. To get rid of denominator. So 5x squared minus 13x equals 6. Or 5x squared minus 13x minus 6 is equal to 0. We'll use general formula. X equals minus b plus minus square root of b squared minus 4 times a into c whole divided by 2 times a. Here a equals 5, b equals minus 13, c equals minus 6. For AC equals minus 120, b squared equals 169. Put the values in the formula we have. Solution is either x equals minus 13 minus 17 divided by 10 equals minus 30 divided by 10 equals 3. Or solution is x equals minus 13 plus 17 divided by 10 equals minus plus 4 divided by 10 equals minus 0.4. Example 38. Factorize quadratic equation. X squared plus 2x minus 3 is equal to 0. We'll solve x squared plus 2x minus 3 is equal to 0 by making it a perfect square equation. Look, x squared plus 2x minus 3 is equal to 0 and convert it. As x squared plus 2x plus 1 minus 3 is equal to 0, add 1 and subtract 1. X squared plus 2x plus 1 minus 3 is equal to 0. Or x2 plus 2x plus 1 minus 4 is equal to 0. Or x plus 1 whole squared minus 2 squared equals 0. Apply the identity. A squared b squared equals a plus b a minus b, so rewrite x plus 3 x minus 1 equals 0. Example 39. Solve the three terms equation. X squared minus x minus 4 is equal to 0. To solve by general formula. Here A equals 1, B equals minus 1, C equals minus 4. For AC equals minus 16, B squared equals 1. Putting the values in the formula we have. The solution is x equals 1 plus minus square root 17 divided by 2. Note the steps. For the verification of the answer, by putting the calculated value of x in the equation. Example 40. Solve the three terms equation. 2x squared equals 4 minus x. To solve, first bring right hand side to left hand side. 2x squared plus x minus 4 is equal to 0. And we solve it by general formula. Here A equals 2, B equals 1, C equals minus 4, for AC equals minus 32, B squared equals 1. Therefore x equals minus 1 plus minus square root 1 plus 32, divided by 2 times 2. Therefore solution is combines as x equals minus 1 plus minus square root of 33 whole divided by 4. Note the steps. For the verification of the answer, by putting the calculated value of x in the equation. We hope you understood well the verification steps. Thank you for watching both of our videos on Algebra Part 1 and this Part 2. Please continue to watch our other videos too. Subscribe the channel and leave your comment. Thanks again.